this example, we have been asked to synthetically divide c to the fourth minus 256 by c minus 4. This is a particularly ugly example because my original function, c to the fourth minus 256, has a lot of missing powers. So the first thing I actually want to do is I want to rewrite this problem, and I'm going to include any kind of powers I'm missing. So I'll have c to the fourth plus 0 c to the third plus 0 c to the second plus 0 c, and then finally minus 256. And then divide by c minus 4. Also in this example, I think they're trying to confuse you because they've used c as the variable. Well, in synthetic division, we use c to represent the value that we're dividing by. So in this case, let's say instead of calling it c, we call it d for divisor. So our d value would be the value that would make that particular polynomial 0. It would be 4. So we're going to put 4 in a box, and then we will use the coefficients off of this particular polynomial as the values that go out to the side. Notice that the coefficient in front of c to the fourth is a 1. So we have a 1, a 0, a 0, a 0, and a negative 256. Leave yourself a space and then draw a line. Start your synthetic division by dropping the 1 down. Multiply the 1 by the 4, put that result up above. Add down, this would be 4. Multiply 4 by 4, that would give me 16. Add down, that would give me 16. Multiply the 16 by the 4 in the box, that would give me 64. Add down, that would be 64. And then 64 multiplied by 4 is 256. Add down, and here I would end up with 0 as a remainder. So here, that's always the remainder. And then my answer, notice that the degree on my original polynomial was 4. This would represent the coefficients on my quotient. The degree of that polynomial would be 3. Okay, so let's write our final answer. We'll write it P of, I guess we need to use C in this case and not X. P of C equals, what did we divide by? We divided by C minus 4. And then what is our answer? Our answer would be 1c to the third plus 4c to the second plus 16c plus 64. And then on this one, you don't need a remainder because your remainder was 0. Only thing I see wrong with this answer is that I have an extra 1 in there that I don't need. So I would think I would just take that 1 out. Just write the first term here as c to the third, 4c squared, 16c, and plus 64. And then this would be your final answer. From here, this example has also asked us to find the zeros of the function. And so to find the zeros, I would need to set this whole right-hand side equal to 0. So c minus 4 times that factorization equal to 0. From here, we want to see if we can factor further. The c minus 4 will not factor, and then the thing that's left in the other set of parentheses will only factor by grouping because it has 4 terms. To factor by grouping, we're going to group the first 2 terms together. So I'm going to open a parenthesis and then open one more parenthesis. C cubed plus 4c squared. Put a plus in the middle always, and then group the last 2 terms, the 16c plus 64. Close 2 sets of parentheses here. This gets kind of messy when it has to do with the grouping symbols. The c minus 4 in the front is finished. from the first group that I've collected, the c to the third plus 4c squared, we notice there is a c squared in common. So I'll pull out a c squared, and we'd be left with c plus 4 after we factor out. And then from the 16 and the 64, we notice we have a 16 in common. So we'd factor out a 16. I'd be left with a c plus 4. And then from there, leave the c minus 4. Notice that these two factors are common, so we're going to write that just once. And then the things that are left over here and here, we would have c squared plus 16. And then this has been completely factored. Notice here that this is a sum of squares which cannot be factored further. So now to find the zeros, we would set each piece to 0. And so here we would have c equals 4 as 1 0. C equals negative 4 when we subtract the 4 over. And then here we're going to have no real result or no real zeros, because there is no way for me to be able to take a number, square it, and add 16 and have the result be 0. So on here where you have a sum of squares, you're going to have no real zeros out of that particular factor.